All right, everybody, what's going on? It's Jacob back at it again for the next video on how to go from zero to hero in Cadence development. I'm your favorite Cadence developer, probably your favorite developer in general. And in this video, we're going to be talking about how to add more keys to an account. So first of all, why would we even do this? Well, actually, before I even go on this, I will mention that if you're watching this video and you haven't seen the previous video, which was part 24, called how to send a transaction on the backend, don't watch this video unless you've watched that one, because this is a direct continuation of the previous one. So nothing will make sense unless you watch that video. Okay. Anyway, so why would we want to add more keys to an account? Well, as I showed in the last video at the very end, what happens when you send a transaction very quickly, when you send a bunch of transactions very quickly from an account, something weird will happen. It'll give you like a sequence number error. So it'll tell you, hey, you can't send this transaction because you just sent another one that has a different sequence number. And we can actually look at this together. So I've loaded up a terminal. Let me clear my terminal a little bit, and let's do some stuff, right? So in the previous video, we were sort of, sending a bunch of transactions from this account. And let's go ahead and just do that again. So let's send a bunch of transactions and see the errors that come up. So we sent one again, and let's just send another one, right? And let's go to this transaction. Let's copy and paste this, and let's go to the web page and go to testnet.flowscan.org and copy and paste this transaction. Now we're gonna get an error. Public key 0 on account has sequence number 7 but given 6, right? So it's saying, hey, something went wrong and you're not allowed to do that. Well, the reason it's saying that is because we sent this transaction from one account and we sent them very quickly, so it's gonna give us a problem. And the reason for that is because in our proposer field here, fcl.proposer, the authorization function, this was our authorization function. And you'll notice that the key ID for the proposer was the same every time, right? So if we go back to our main.js, you'll see the proposer's authorization function, and authorization function always uses key ID, which is always 0. Now that's where the problem is. You can't send a lot of transactions on one account very quickly that all use the same key ID. The way to fix this is to add more keys to an account. So that's what we're gonna go over today. All right. So I've loaded up the view source here, /testnet/account /my testnet address. In the previous video, I was saying that we didn't need this in our flow.json, but we will in this video. So if you got rid of it, make sure to add it back, where you have your account address, your private key, your ECDSA, whatever you have. This could be secp256k1 or it could be p256. We're going to go over both those in this example, and then your hash algorithm right here. Disclaimer, this is a test for private account. There's no actual flow in there, so middle fingers to everyone who was trying to steal money. All right, so how do we add keys to an account? Well, let's actually open up a file here, and we're going to call this cadence code. So cadence, like that. And we're going to add a new transaction called add key.cdc. All right. So I'm going to be working from my notes here. So if you see me looking back at my terminal over here, don't be mad at me. Okay. So we're going to do a new transaction. So let's do a new transaction. This is a CDC file, so we can do that. And we're going to pass in a public key, which is a string, and the number of keys to add, which is an int. Now, before I keep going, I just want to say a massive thank you to Amit, who helped me figure all this out when I was trying to do it. So thank you to Amit for helping me out. You've been such an incredible help to me, and hopefully everyone that's watching this video. So the next thing we're going to do is open up our prepare statement. Now, obviously, this is going to be the signer, which is the auth account, right? This is just standard flow transactions. And then we'll also have an execute phase down here, okay? So just like that. Now, we're actually not going to do anything inside the execute, but inside the prepare phase, we're going to convert our public key to a hex. So what we're going to be doing in this transaction is passing in a public key to add to our account, and then it's going to add that public key to our auth account that we're signing with, right? So obviously we're going to sign this transaction on behalf of this account, and it's going to add the public key again, but with a new key ID, right? So what we're going to do is we're going to convert the public key to bytes. So let's say let bytes equals public key dot decode hex, like so. And the next thing we're going to do is we're going to actually create the new key ID. So equals a public key. And inside the public key, we're going to say the public key is bytes. That's what we just decoded. And the next thing is going to be the signature algorithm. Now for us, because in the previous video, I was using secp256k1, that's what we're going to use here. If you use the p256 one, then I'll show you what to add. So you would add signature algorithm. This has to be capital S. signature algorithm dot ECDSA underscore P256. This is dependent on what your key is, right? So if we go back to our sort of page here, you'll see the public key that I initially added was ECDSA SecP whatever. If yours says ECDSA P256, then you'll need to put this here. But again, because I put this one, I'm actually going to copy this and bring it over, and so I'm going to put this one instead. Okay, cool. So there it is. There's our new key, and then we're going to say var counter equals 0, and this is just so that we can add the number of, we're going to add like X amount of things here. So we can say while, the counter is less than number of keys to add, we're just going to do a for loop, and then here we're going to say, increment, so counter equals counter plus 1, and then the last thing here is signer.keys.add, so we're actually adding the key to the account now. The public key is the key that we define above. The hash algorithm. This should always be hash algorithm with a capital H here. Hash algorithm dot SHA-3, unless you changed it, but usually you would use this one, SHA-3 256. And then lastly, the weight. So what is a weight in Cadence? Well, if we go to our page here, you'll see that this key right now has a weight of 1,000 out of 1,000. So the max weight you can have is 1,000, and the least weight you can have is 0. In order to actually pay and authorize a transaction, your total key weight, so the total amount of keys you sign with, needs to have a weight of 1,000. However, for proposing, right? So I'm talking about the three phases here. There's proposing, there's paying, and authorizing. For these two, your key weight has to be 1,000. Your total key weight, right? So you can sign with a key that has 500 and then another one that has 500. That is a combined 1,000. For the proposer, it doesn't matter. So if we want keys with different weights, what we can do is just add a bunch of keys that all have weight 0, and it will work perfectly fine. All right, so here's our transaction code. We're gonna go ahead and save this, and now we can actually run this transaction on behalf of our account that's stored in our flow.json here. So let's go ahead, let's clear this and say flow transactions send. Now I'm just gonna run this to see what the help page is. So let me actually expand this. And it says, so you send the file name and then any arguments here. So let's say flow transactions send the file name, which should be /add_key.cdc. And then now it takes in the arguments. So the arguments should be the public key and the number of keys to add. So let's go ahead and do that. Now the public key that we're going to use, right? What you could do if you wanted to is you could generate a new public and private key pair. We're just going to use the same public keys here. So let's copy and paste this public key that's already added to my account. And the reason for that is because this public key matches the private key that I made in the previous video, right? So in my authorization function, when it's doing all the signing and stuff, right, it's going to already have my private key here. And so it'll sign with that private key, which matches this public key. So that's why it's going to work. If you wanted to add different public keys, you would need to add you would essentially need to add you would need to store that separate private key somewhere so that when you're signing with that public key, you use that private key, right? But that's a little complicated. So let's go ahead and just add this public key again. So we're going to copy and paste our public key, and then let's add, I don't know, 5 keys, right? Okay, and I also totally forgot that we put add key in a folder. So this is actually /cadence/add key, right? Because inside our we put it in the cadence folder. So if we go ahead and we run this transaction, it's going to say expected delimiter got identifier hash algorithm. Let's see what I did wrong. So if we go to our function here, oh, it's because I forgot to add a comma on this line. So I totally forgot to add that comma. Okay, cool. So let's go ahead and run this again, and let's see what it says. So it should go through in a second. Oh, and the last thing I forgot to do was I forgot to say --network equals testnet and --signer equals testnet account. So for some reason I'm forgetting a lot today. But we want to say the network is on testnet because obviously we're doing this all on testnet, and the signer is testnet-account. Now where that's coming from is inside our flow.json, we named this account, the one that we're adding the key to, we called it testnet account here. So that's why we put that right there. So now if we run it, we should get a transaction ID, boom, and it's waiting for the transaction to be sealed. And once it does that, we'll actually be able to go to our view source and see the keys that just got added, which would be really cool. So let's go ahead and wait for it. And if there's not any errors, okay, so it doesn't seem like there's any errors. Now we can go to the view source and look. So we added public keys to our account. So now there's a bunch of keys. It added 5 of them. They all have weight 0, right? So yay. And you can see they all have the same public key, which is good. That's the one we added. We have the private key for that, so the signing is going to work totally fine. All right. So if we go back into our main.js file, we want to actually have another function. Maybe let's call it authorize function proposer, and we're going to import this from the authorization file again. So authorization function proposer. Now, of course, we haven't defined this yet, but the point is that authorization function proposer will iterate over the keys that we have, so that every time we send a transaction, it will come up with a new one, right? So it'll come up with like the next key ID in the loop, so that it sends it with another key ID. So let's go to authorization.js. Let's copy and paste our authorization function, and let's call this one authorization function proposer, and we'll have to export this one as well, right? So that we can use it in the other file. All right. So what we're going to do inside of here is we're going to say, instead of using key ID, we're going to use key ID, we'll call it like iterable. So let's just call it iterable. Let's copy and paste it into here and here. And what we're going to do is we're going to store a variable up here. So let's call it variable key ID iterable equals 0. So it's going to start at 0. But inside of here, we're going to say, so if key ID iterable is greater than, and let's see how many key IDs we have. So the max key ID is 5. So if key ID iterable is greater than or equal to 5, then we want to set key ID iterable equal to 0. So back to 0. Else, let's just add to it. So key ID iterable plus plus, right? So it's going to loop through the key IDs every time we send the authorization function proposer. Awesome. So if we go back to our main.js now, what's going to happen is, so we can't do node main.js over and over and over again, because that's just because what that does is every time we run the command, it's just going to set the key ID back to 0 again. So that won't like properly test it. But what we can do is we can add multiple calls in here and see what happens, right? So that when we run node main.js, it runs this multiple times and it'll increment the key ID every single time. So if we go to our, let's go to our terminal and let's run node main.js. And it's going to print all the transactions like so. So it just ran 3 of them very quickly, right? So let's copy and paste this transaction ID. And let's go to our web page here. And let's paste this transaction ID. And let's click explore. And you can see success. So there were no problems with the sequence number. And if we go to our view source, you'll see, you can actually see which ones got run. So I actually, the reason this one says 2 is because I messed up in the middle of the video, which is why I'm cutting sometimes. But you can see that that multiple of these keys are actually being run. So it's using, it used this one, it used this one, it used this one. So it's using multiple keys in order to send us transactions, which is super cool. And you know, if we look at these numbers, let's actually go and run node main.js again. And it does 3 more transactions. And if we go here, when the transactions end, we should see that these sequence numbers get incremented. And essentially, sequence numbers on flow are how many times this key ID has been used to send a transaction. So if we, wait a little bit here and maybe even like refresh the page, you'll see this one's now 10, this one's now 3, and this one's now 2. So each of them got incremented. Now, to be honest, I'm not quite sure why it's skipping this one, but that's sort of beyond the scope of this video. And I hope that helps all of you. So I guess the main recap is that in order to send from the proposer and not have like errors on setting transactions super fast, you can specify many key IDs with weight 0. Use that one for the proposer, but make sure you're still using the old authorization function for payer and authorizer, namely a key that has weight of 1,000. So for our regular authorization function, you'll see we're still using key ID 0, which has weight of 1,000, and we can check that right here as well. So hope this was helpful, and I'll see you all in the next video.